All right, so I'm going to do something a little different with this lesson. I'm going to look at a few of the problems that I think you're going to have with the assignment and just kind of, help maybe go over a little bit that we could maybe help structure them so that it might be easier to get the actual assignment completed. So numbers 4 and 5, if you're looking at numbers 4 and 5, those are rectangular prisms. And number 4 and 5, the first thing you should do is draw your net for your rectangular prism. And this is what the net for the rectangular prism looks like every single time. So you've got your 1, 2, 3, 4, 5, 6 different spots. I would call this the front, the right, and the top. And then, the base is at the bottom down here. So I would start here with my base. And then I know the top is going to end up over here. And here's my right, here's my left, and here's my front and my back. Because if I just let the box fall, and that's the way it goes. And then you would start with the base. What are the dimensions of the base? Calculate this one, which means you've got that one also. And then I would move to the right, calculate this one. It also has this. And then the front, which is also the back. And there you go. All right. Now, number 6 is a little different because it isn't a rectangular prism. Number 6 has the dimensions of 1 and 1 and then 3, 3, 3. So it's 3 back. This is a 1 and this is a 1 and this is 3 here and 3 here. Now, this is a difficult problem, okay? And the reason is because we could make a net out of this, but it would look an L on the front and it would look an L on the back. And then there would be the base, and then there would be a left side, a right, and then a top, and there would be another right and another top. So what we should do on this one is just maybe figure out each one individually. Now, so this one over here is really easy to do. It's a 1 by 3, and it's just a rectangle. And it's a 1 by 3. And then you can figure that that's going to be 3. 1 times 3 is 3, and there you go. Well, this is also 1 times 3 on the top. So there's another 3 right there. And I'm just going to circle that because that's what that's going to end up being. Now, the problem here is if this is 1 and you want to use 3 here, you can't use 3 for the width of this because we need to make that. Because if we multiply 3 by 1, we're going to hold this whole thing in 3 by 1 over here. So what we need to do is we need to figure out how big is the face here on the front. And so you can figure this one, because it's 1 right here, times 3. So this part of this front is 3, which means if I've already taken 1 away from this, that means this is now 2. Now, if that doesn't make sense, rewind the video and watch it. If this is 3 over here, I can't count this square again. I've already counted it. It's 1, 2, 3. I can't count it again. So now I'm going to count this over here, and it's 1 times 2, which is 2. So this front side is 5, which means the back side is going to be 5. The bottom of this is going to be 3 times 3, and the back of it's also going to be 3 times 3, this section back over here. And then you need to figure out what these 2 up here would be. It's not 3 long, it's only 2. And this isn't 3 tall, it's only 2. So that's what I would do, is I would figure out how many sides are there to this thing. Well, if we take all this stuff back out of here and look at it again, you're going to have to calculate 1, 2, 3, 4, 5, 6, and then 7 and 8. There's 8 different sides that you have to calculate. I would do them one at a time. Shade them in once you figured it out. Draw arrows back and forth. Okay? It's not a very easy problem to do. And the net on it would honestly confuse us right now. So we're not going to talk about that one. Number 7 looks like this. Number 7 has kind of like a house, right? It's got this rectangular prism, and then they want you to find this total surface area of the doghouse, including the door. So what we have here is a rectangular prism. So we're going to pretend that this is a rectangular prism, okay, and a triangular prism, which is really what it is. There's a rectangular prism and a triangular prism. So we're going to count the rectangular prism all by itself, and this is a long problem, and it's a rectangular prism like this. Now, we're going to do all of this. There's the base again, and we've got the top, the right, the left, the front, and the back. Now, the only thing that we don't need, however, is when this thing is put back on here, you know, we don't need the top of that thing anymore. We don't need to know. There's a section in there like that that we just don't need anymore. There's a top of that thing that's really not surface area because the triangular prism takes that. So we don't need that. And this would have been the top. And I don't need to know the top anymore, so I'm not even going to count it in the problem. And then I'm going to calculate this stuff, figure out what that is. Here, if my triangular prism always looks like this. If you're going to solve these things without pictures, you are just going about it incorrectly, all right? Now, here's what happens when you make the net for the triangular prism. You drop the back out, so here's the back, and then you drop the front down, here's the front. The base is right here, because that's the bottom, and then the two sides. So we've got a right and a left. Now, you don't need, when this thing comes back down and boom, back on top of this thing, we're not going to need the base because it's inside. And we're talking about the surface area, what's on the outside of this thing. So we're not going to need the base, just like we didn't need this over here. We don't need the top on this one because it's going to be taken up, and we don't need the base of this. And that's like, so we're going to calculate this. It's the same as this. Calculate this. It's the same as this. I'm going to count the base on this one. I'm going to count my right, which is the same as my left over here, and my front, which is the same as my back, but then I'm not going to count my base. So again, when we're making we're making sense of these problems, and we're using structure to do this, we have got to figure out what we're counting and what we're not counting before we do the problem, all right? The last one, number 9, wants to know what the surface area of the ramp that Eddie has built, the surface area of the ramp that Eddie has built. And this thing looks like this, okay? It is a there's a trapezoid on the front. So this is a different idea here, where you've got a base and a top, and then you've got these two sides, and then you've got a trapezoid on each side. So what we could do with this is we could draw a trapezoid. We could draw our 1, 2, 3. So I want to make my base first, and I'm going to have a trapezoid come off of each of the bases, and then I'm going to have two sides that come off like this. So here's my trapezoids on both sides on my base. And here's my back and my front, my right and my left. And then I also need my top still. So the base and the top, it's just a little different shape now, okay? But it's still the same thing. So I'm just making a net. I've got my base, my right, left, and top, and then my front and back are trapezoids. Now when we do this, this is a length times width. This is a length times width. This is a length times width. And this is a length times width. But the trapezoids themselves are not base times width. There is a measurement of 16 on the top, and then it's 16, 16, and 16, and 3 times 16 is 30, 48. So it's 48 on the bottom, and then it is 12 tall. 12 tall. Now, the formula for the area of the area of a trapezoid looks like this. It's the first base plus the second base divided by 2 and then multiplied by the height. So it's something times the height. So this is base 1 and this is base 2. So you add these together on the top, you add them together, you divide by 2, and then you multiply by 12, which is the height. So it's these two averaged, found the mean of them, and then multiply that by the height. And that's one of these faces. And if once you find the first one, you have the second one. And then everything else is just the length times the width. Okay, so that's how you set those problems up. If you still have issues or you still have difficulties, send me a message or join one of the live groups. Thank you.